Hello all, in today's lecture on transmission and distribution, we are going to see about the types of transmission systems. So in the previous lectures, we have learned many things about the transmission, distribution and what are all the modeling techniques that we can use in order to know the inductance and capacitance values. So in this lecture, we are going to deal about the types of transmission system. So before going into the topic, let us recall what is a transmission system. So a transmission system is the main part in generation, transmission and distribution because we generate some power in one place and we have to distribute to the consumers to use the electricity. So transmission plays a very important role in transferring the generated power to the distribution side. Which component steps up the voltage for transmission in a power system? So as we all know, the transformer is the only device which can step up the voltage for the transmission in a power system. So we use step up transformers in order to step up the voltage during the transmission in a power system. So here we have clearly mentioned the components of electric power system, which is transmission, generation, transmission and distribution. So in this video, we are going to see about the introduction and the types of transmission system. Whereas we have two types of transmissions, AC transmission and DC transmission. So this is about the structure of power system which we have already learnt. So generating station which is indicated in red, transmission is indicated in blue and distribution is indicated in green. Whereas transmission voltages will vary from 765 kilovolt to 138 kilovolts. So coming to the transmission system, so the power plants with sources of electricity distribution, transmission lines which conductors that carry electricity, substations which facilitates to reduce voltage for distribution because the high voltages cannot be used for the household appliances. So we have to step down the voltage for our need. For example, if it is of 3 phase, we should reduce to 415, or if it is single phase, we have to reduce for 230 volt. And load centers are the areas where electricity is consumed. So coming to the types of transmission system, so generally AC and DC. In AC, it is again divided into three, which is short transmission, medium transmission and long transmission. So in medium transmission, we have two models, pi model and T model. So short transmission is we can transmit for a particular distance, whereas medium is greater than that and long transmission is a very high distance. So types of AC and DC, whereas voltage level which is primary transmission and secondary, and nature of construction may be overhead or underground systems. So this is simple diagram of generation, transmission and receiving station. So generating station, it will primary transmission we call it as 400 kV which is sent to the receiving station, and that is reduced to 132 kV in secondary transmission and which is given to the substation. So here we have a clear picture for overhead and underground transmission, whereas the first picture gives the overhead transmission line and second one is underground. So when we come for a comparison like overhead or underground is the best. So overhead has some difficulties like if there is any break of line and the lines, it will cause to damages and more accidents are possible, whereas in underground accidents may be reduced. But whereas in overhead, if there is an issue or a fault, we can easily know where is the fault and we can correct it easily, whereas if it is underground, we have to search for a distance. But nowadays we have many projects to detect the fault in the underground system, but still we have to dig the land and again reconstruct, so which will be very costly. So this is the basic difference between the overhead and the underground transmission lines. So when we come for the applications of power system in real world, as it is used in day-to-day life, mainly in residential areas and industrial applications and transportation systems. So transportation is like metro, electric trains and EV charging stations are the main transportation systems. So in this video, we clearly discussed about the transmission system, function of transmission and types of transmission systems, types of current, voltage levels and nature of construction, either it is overhead or underground. And function of transmission is, it is the from power plant to the substation. This is the main part, and substation to the load centers, which transfers power from generating station to the distribution station. So coming to the applications, it is mainly used in residential areas, industrial applications and transportation systems. So coming to a quiz here, the main function of transmission system in a power network is to transfer power from generating station to the distribution system. So in AC transmission systems, which of the following is a major advantage? It is easy voltage transformation using transformers. So these are some of the references of today's discussion. Thank you.